Problem number 7 on YDSE. And this also slight variation of a standard setup. This is a monochromatic beam. Rest all is standard YDSE apparatus, but this is not forming normally. It is incident at angle alpha at the normal. So if you draw a plane containing the slit, it is at angle alpha here. What we need to find, what is the angular position of central bright fringe here? Okay. So in this case, if we consider a wavefront passing through S2, now these 2 points will not be in the same phase. So if you have to find, these are 2 rays here, which point on this ray is in the same phase at S2? We draw a wavefront from S2. Wavefront is perpendicular to direction in which the wave travels. So if S1 and this is perpendicular here, S2 and M are in the same phase. Okay, so if you consider, that's how we find 2 particles which are in the 2 points which are in the same phase. So these 2 points are in the same phase. What is CBP here? CBP will form at a point on the screen. Let's call this point P, where phase difference is 0. And phase difference is 0 here. So here also phase difference, 2 rays reaching here has a 0 phase difference. They'll have 0 phase difference if path difference from M to P is equal, path length from M to P is equal to path length from S to P. So both path lengths have to be equal, or path difference from M and S2 has to be 0. So we have to take path difference has to be 0, starting from points which are in same phase. So equating the path length here, S2P is from this source. And from here, MS1 plus S1 in S1P. And these are the path lengths here. What is MS1 here? Okay, MS1, this length. This length is alpha. This is 90 minus alpha. This angle also is alpha here. And if this angle is alpha, this is D. This will be equal to D sine alpha. So MS1 is D sine alpha. And from this equation, we already know S2P minus S1P. And let's say this central bright fringe is forming at an angular position of theta here. So this path difference depends on angle theta here, and which is equal to d sine theta. So if we substitute these 2 values in this equation, S1P, we bring it to this side, it becomes S2P minus S1P, which is equal to d sine theta becomes equal to d sine alpha. So what is the condition? The angular position of central bright fringe will be same as angle alpha. That's where, and hence angular position of central bright fringe is equal to angle of incident ray with the normal. That's a position.